So let's see the geometric progression. So suppose if you for take an example, this is a series. So here you can see that here 7 into 2 becomes 14, then 14 into 2 becomes 28, 28 into 2 becomes 56, then 56 into 2 becomes 112. So you can see that here you can see the this common multiplier is called as common ratio, which is say r is 2, and this first term is called as a. So a is 7. So if you like generalize a geometric series, you can write it as in this form. The first term is a, second term as a r, third term as a r squared. Similarly, fourth term is a r cube. So you can see that for fourth term it is a r cube. So like 4 minus 1. Similarly, for fifth term it is a r 5 minus 1. So similarly, if you go for the nth term, you will get a into r n minus 1. So this is the nth term of a GP. So nth term of a GP is a into r n minus 1, where a is the first term and r is the common ratio. Now let's find the sum of the nth term, like n terms of a GP. So for example, if suppose let's see if a GP is such that a plus a into r plus a r squared, suppose the final term is a r n minus 1. So if you multiply the first equation with r and subtract it again to the so if you multiply with r, so it will become a into r. So now what you have to do is you have to shift it one position in the rightward direction. So what will be here? So here you will get a r. So the first term into r will come here, second term into multiply by r, it will become a r square. Similarly, if you see the a r n will come here and a r n minus 1 will come here. So now if you subtract both of this equation, so you will get 1 minus r into s. You are actually subtracting this. So what this will get cancelled. So this will get cancelled. So what is left? A minus a r power n. So if you take out the a common, it will become 1 minus r to the power n. So s will give you a into 1 minus r to the power n by 1 minus r. So this is the case when r is less than 1. But if suppose r is greater than 1, the same equation will become a into r n minus 1 by r minus 1 when r is greater than 1. So now let's see the sum of infinite series of a GP. So that is s is a plus a r plus a r squared, so on till infinity. So it is represented by s infinity. So here like you just have to, and here you have to keep in mind that r is always less than 1, then only it is a finite summation. Otherwise it will, if r is greater than 1, it will be a like s in infinity will also become infinity. So when r is less than 1, what will happen, that this formula, let's write it down, a into 1 minus r, then 1 minus r to the power of n. So you will see that when r is less than 1, if you multiply, if you take r to the power of n, which is tending to infinity, so it will, the whole r to the power of n will become as 0 as a limit. So this will become 0. So you will get your final answer as a 1 minus r. So I hope, so we total 3 results which we have seen for our any GP is that, suppose this GP, so the nth term of a GP is a r n minus 1, the sum of n term of a GP is a r n minus 1 by r minus 1, and if suppose if an infinite GP is there, in that case, or we have this where r is less than 1. So this is the 3 results that we have to remember for a GP. So let's take a question. Suppose we will, in one question only we will see all. So suppose a question is there, suppose 7 then 721, then 63, then suppose 189, and so on. So first you have to find the first term is a, which is 7. Then common ratio is, you can see here 3. Then here also it is multiplied by 3. Here also it is multiplied by 3. Okay, so our common ratio is 3. No need to find the nth term. Like you can find, suppose if you are asked, suppose you have to find the 50th term of this. So it will be a into r to the power 50 minus 1, which will become a into r to the power 49. So 7 into r to the power 49 means 3 to the power of 49. So this will be your 50th term. So now let's see the sum of the 50 terms. So your sum will give a into r to the power of n minus 1 by r minus 1. So your a value is 7 into r is 3 to the power of total n is 50. So 50 minus 1 by r minus 1, that is 3 minus 1. So your answer is 7 by 2, 3 to the power 50 minus 1. So let's see one more question where we will see the sum of infinite series. So for example, s infinity is 1 plus 1 by 3 plus 1 by suppose 9 plus 1 by 27 and so on till infinity. So you can see that we know that the form you have to find the s infinity. So like you can try on your own. So we already know the formula. So what is the formula? A by 1 minus r. So a, we have a is 1, which is 1, and r is 1 by 3. So you're multiplying it by 1 by 3 each time. So 1 minus 1 by 3, that will give you 1 by 2 by 3, which will give your final answer as 3 by 2. So now let's see geometric mean. What is geometric mean? So geometric mean. So if suppose A, B and C are in GP, so B is called the geometric mean. So you can write is like B by A is equal to C by B, because this common ratio should be same for both. So it will give you B squared is equal to AC. So B will become root AC. So B, which is the geometric mean, is the root of first term into the last term. So for let's see one more example. Suppose you are asked that suppose 7 is the first term and you have to insert three geometric mean in a sequence between two numbers. So suppose GM1, GM2, GM3, and suppose the last number is 21. So how you will do these types of problems? So let's see. It is not very easy. So suppose here our first term is 7 and our last term, that is actually 1, 2, 3, 4, fifth term, which is a into r to the power of 4 is 21, and we know our first term is 7. So r4 will become 21 by 7, that is 3. So r will become 3 to the power of 1 by 4. So now we get our first term and rth term like in common ratio. So we can find GM1, GM2 and GM3, which are the three geometric means. So like GM1 is a into r, GM2, which is the second geometric mean, is ar square, GM3, which is the third geometric mean, is ar cube. So just put the values. So a is 7 and r is 7 and r is into 3 1 by 4. Here 7 into 3 2 by 4, and this is 7 into 3 3 by 4. So like this is the 3 geometric mean if you are asked in a question to insert between two numbers. So that's it about geometric mean. So in next lesson we will see about harmonic mean.